Hello students, this is an overview of the orientation assignment. The purpose of the orientation is to refresh the object-oriented programming concepts that you have done in earlier classes. This course is going to be C++ based, and it presumes a working knowledge of OOPS concepts of C++, especially writing classes and objects, and other features like inheritance, polymorphism, copy constructors, operator overloading, and class templates, which are going to be used to build our data structures and examine the algorithm complexity. So this course is going to be using a lot of these programming concepts. So the purpose of orientation is to refamiliarize yourself. Now, what we're going to do here is we are going to start off by using a dynamic array. A dynamic array is an array that gets created on the heap. And as you know, if we are working with data structures, we want to be sure that we are not clogging up memory, and memory on the heap can be allocated and then it can be deallocated. So that's the advantage of doing dynamic arrays. So that and the other important thing is a lot of times the size of the database is not known in advance. It can grow over time. And again, dynamic arrays allows us to allocate an array, and you can allocate an array and the size of the array can be provided at runtime. And then we can also do some other tricks. And as we move on in the assignments, we can see how we can use this concept to increase the size of the array and dynamically reallocate another array and copy stuff over. So these are things, but for now we are going to be starting with a value, a certain value, and that value turns out to be a size of 300 because we are going to be inputting data of size 100, and then we are going to be running the same program with a bigger data set which is of size 200. So then again, you see it's valuable to use dynamic arrays for this kind of activity. As you can see, this is how we are creating the dynamic array. Now, what we are going to be doing though in our assignment is we are going to be creating a dynamic array of pointers. So our array is going to end up having double pointers and say database is equal to new int star size. So this is a declaration that is an array that points to an array that contains pointers to integers. So for example here, so this is going to be database here, let's say. Oh, this thing is upside down. So let's do that. So here we've got an array of pointers, and each of these is going to be pointing to ints. Now so this is what a general dynamic array looks like. So in this case, there are ints here, which again have gotten allocated from the heap. But in the actual assignments, each one of this is going to be a song object. And that's what our dynamic array is going to look like. And then database is going to be a pointer to an array which contains pointers to song objects. So this kind of, when using pointers, sometimes it's useful to draw a pictorial view of what's going on, just so we know how to traverse the links. Of course, when we are done with all of this, we can delete the database, and so what we can do is we can delete our database once we are done. And again, the important thing is to set that pointer to null pointer, because even if you delete the memory, if you delete all of this, database is still going to be pointing to an area of memory that's been deallocated, and that's dangerous. So now to come to the actual assignment, The first thing is to create a class called song, and a song consists of a title, a singer, and a chart position. Now create the dynamic array of pointers to song objects. Initially read from a file called songs data that contains 100 songs, and fill the array. Then we are going to, because this data is unsorted, we are going to be using a selection sort algorithm. So here's where our algorithm and data structures relationship comes into play. We've got data that's stored inside an array, and we are going to be doing a selection sort procedure on this and count the steps and see for this particular data structure, how long or how many steps did it take for us to accomplish the sort, and print the sorted array. Now that it's sorted, we'd like to search through the array by using a linear search and checking to see how many steps were taken. Now, what we are going to do is we are now going to double the size of the database and perform the exact, so run the program one more time with this bigger file and see how many steps see how many steps it took this time for an array of 200 elements, 200 songs, and see how long or how many steps the selection sort procedure took and how many steps the search took, and try to see what is the relationship between n, which is the size of the database, and the number of steps that's taken. So that's going to be part of your reflection. So now I'm going to go over the template that's given to you. You have been given a template in which a lot of code has been written, and because I understand that that some of you may be coming in from either practice with a different language or might be a little rusty with C++. So this is a good time to go through the code and refresh those concepts. So two things. One is the orientation assignment document itself, and the other is the template that will be helpful to you. So the orientation assignment contains the detailed description of what you need to do, how you need to submit, and so on. So you are expected to write a class called song. Now, how are you going to get started? That's given to you. It's a zipped file, but what is inside the zipped file is this song.h. Now, this is completely written to you. So in your assignment, when it says write a class called song in a file called song.h, know that this file has already been given to you in your template. Now, with regard to the template, if you need to make any changes or there's some syntax issues or any other issues with the template, it's not perfect. It's only meant to help you get started. So please feel free to use that as a skeleton and change whatever you feel comfortable doing. Now here are the methods or the functions and the getters and setters. The important method that I'd like to point out, which again is written for you, but I would really urge you to examine this and refresh it, is the overloading operator. The less than operator works very well when we compare integers, for example, or when we compare characters or compare floating point numbers. But when we would like to compare objects, why would we like to compare objects? Because we'd like to sort these objects, and we need to impose some kind of ordering. And so we are going to use in this program the less than ordering. But how do we know that one song is less than the other? Well, here's how the less than operator gets overloaded to compare inside each song object the value of the chart position, and two songs are one song is less than the other if it's got a lower chart position value than the other. So that's how this is going to be implemented. How is the output operator overloaded? That's also been done for you in that it simply prints out it simply prints out a song, and you can just do cout s, and what it will do is it will convert that object to a string and print that out for us. So write the implementations of these methods in a file called song.cpp. Well, here is the file called song.cpp. And as you can see, there is some stuff here which is called to do. The default constructor is written for you. You're expected to write. So wherever it says to do, you're expected to fill in the code. Wherever it says given code, then you can simply use this code as it is. And here, get chart position, you've got the to do. I've just introduced return 0 to make this template work syntactically, compile, but you need to change this to whatever value. Now this is the overloading operator, and I have written this code for you. Please, you will be needing to do a lot of operator overloading in the coming assignments. So please get comfortable and familiar with this. And then again, this is the to do. So this is what your template is going to look like, where it says given code. You don't need to worry about writing it, but you do need to examine and see how this code was written. And if you would like to do it in a more efficient way or a different way or in your own style, you're absolutely welcome to do that. But where it says to do, you need to write the code. Now, so the classes have been more or less given to you. This is the data file, which contains, this is the songs.data. Songdata.txt. Oh. So this is the songs data double.txt. So this one contains 200 entries. I'm seeing that songs data is incomplete here. It's a test one. I think it got overwritten. What I'm going to do right after I make this video is I'm going to simply take 100 songs out of here and put them into songsdata.txt, right? So this is what the data file looks like. You've got the song, the singer, and the chart position. So there will be two files. One will be the song data, which you will run first time. Then you will be using the songs data double, which you will be using for the larger database. Now, what output should you expect? The output that you should expect is when you run it for the first time, then as you can see, all of these have been sorted. You can see according to chart position, all of these 100 are going to be printed. Then you're going to print the top 10. So, and just before we print this, when we go right up here, it says the sorting has been done and the number of steps for selection sort is 4950. And then you print the sorted database, and then you're asking for the search, which song, and you say ice cream, and the song ice cream was found at position 92, and the number of steps taken for linear search is 92, and that's not surprising. Now let's look at what happens when we run it the second time with the bigger database, and here the number of steps is 19,000. The first time it was 4,000, now it's 19,000, and when we go to the search, I'm deliberately searching for something at the end of the database. I'm looking for DNA, and DNA was at position 197, this title DNA. I search for it, and it actually finds it, brings that up, and records a number of steps. So let's go into the main program. The main program creates the database. A lot of this stuff is actually given to you. It creates the database. It populates the database by reading it from songsdata.txt into the data array, and it returns the size, how many entries are actually there, because remember, I have set here size is equal to 300, which is enough to hold 300, but initially I'm doing 100, second time I'm doing 200, so I'm actually absolutely safe here. Remember, I could have actually passed a variable instead of constant because this is a dynamic array, but I just chose to do it this way. And then here, once I populate the data, I'm not going to print it just now. I'm going to sort it first because that's what the output looks like. And the sort returns to me the number of steps taken for the sort. Then what I'm going to do is I'm actually going to print the data here. So after you sort it, print the number of steps, print the data array. I'm going to say print the sorted data array right here. Print the sorted data array. And then here, print the top 10 songs, search for the song, print the number of steps taken. Now, here is where I'd like to highlight the documentation. You do need to follow all the C++ guidelines. In addition to that, you need to follow REM. Now, REM is what does this function require? In terms of it requires a non-negative size. This tells us about, requires tells us about the input parameters. Effects tells us what is the actual functionality of the function that you're writing. What does it do? And modifies tells us what are those variables that actually get modified inside the function that we need to take care outside the function. Now here it says you are given code here, which means a selection sort has been written for you. Let's go down here. Populate array. That has also been given to you, and I would really urge you to go through and see how this code has been written. Now, print song is something that you need to do. Now, and I've written the REM for you so you know what you need to do. And you can look at the output to figure out what does the what does the output need to look like. And then print tops 10 is something that you need to write. Now, here, the linear search, you need to go through the array to find the song by title, right? And you can do this by using the method getSong. So this would be a good function for you to use in your linear search. So, and that is something tracing through the array. You can, linear search is something that you can do. You can go through the array and then you can take the song title. You can compare the titles of the songs, and you can actually use string compare for comparing the titles. And if it is found, you can actually return it. So basically the code that you need to write is very little, but you do need to go through all of this code to figure out how to write going forward, what is expected of you in future assignments and what your expectations can be with regard to the size and the complexity and the documentation and the output expectations. Now to go back to, so here I have gone through the template right here. And with regard to the submission format, all the code files and the data files need to be zipped into a file, which is A0 for assignment 0 orientation, and then with your student ID. It says include data files and all CPP and header files, but do not zip the document file. Which document file are we talking about? The document file that you need to submit is your output.txt and your output double.txt. And I will expect that your program needs to be functioning, and I would like to know that this is your program because you need to write your program needs to print your student ID and your name at the top of your output. So, and we will be running your program to make sure that it actually does work as you have suggested. What else? You will need to submit your output files, which is called the document file. It's going to go into a document called A0 output blah 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 .doc. That's where your output.txt and your output double.txt is going to get pasted, right? Do not zip it with your code files, because the grading script that we'll be using will just throw out all your assignments. Now, the rubric for this is given to you. At the bottom of this, you will be given 50 points for this assignment, and you will find at the end of each assignment on Canvas, you will actually see a detailed rubric which will tell you how the grading is done and what the grade distribution is for the different features of the program.